another change to the right. As we approach these obstacles, we don't always see the lane coming up, but we make the prediction about where it'll go, and it changes appropriately. Especially in this change to the left to an inner lane, we don't always see this lane, but we can make an accurate prediction about how to turn, to find it, and then follow it as appropriate. And so back to you.
Thank you, Matt. Now for our special functions. Our first special function is to track the ball. We were the first group to implement this, and as you can see, some other groups have done it as well. So it was obviously a good idea to do it. We use a speed controller. The speed controller is actively calculating the speed of the vehicle, and we can pull up to 5 times our own weight while maintaining speed. Unlike some other groups, when we remove the weight from our vehicle, it doesn't just jet off for like 5 meters and then resumes at normal speed. It deaccelerates very quickly in an appropriate time frame so that it's safety oriented.
I'll be talking about our second special function, which is the wireless remote. This allows us to debug and perform an operation in a very safe manner, as it has an emergency stop signal as well, just in case if things do go bad, we just press the button and it shuts down. And we also have a lights implemented as well, our brake lights, as in real life. So if the vehicle stops in a 3 obstacle situation where there's no obstacle in each lane, the brake lights turn on. If it's in an emergency stop mode, the brake lights flash like a forward movie flash in real life. Now back to the track.
Thanks, Mohit. Before we actually demonstrate the speed controller, we'd just like to show you our remote button box that we made custom. If you can just bring it closer. So here's the button box. We have a go stop switch, speed controller on and off so we can toggle that. We have an emergency stop that's always good for safety, and also a full system reset. So if I, for instance, put in an e-stop, you should see the LEDs start flashing, and then if we put it in a stop mode, we have full LEDs on. So now we're going to demonstrate the speed control.
Yeah, very speed limit.
Colin, we're running out of time.
Just to get the switch on. So I'm going to have the speed controller on. Just note the speed of the vehicle without any weights on it, just the trailer, which is about approximately 5 pounds or so. Okay, now we're going to put on, Matt's holding 7.5 pounds. It's going to try to maintain the same speed. Going to do a full lap. Now I'm going to turn off the speed controller to see the effect. And now I'm going to turn it back on, so it revs up the motor. And now Matt here, this is important to note because when we take the weights off, without the speed controller, it would jet off. But here, our car decelerates. Okay, that's everything with the speed controller. Back to you guys. Thanks.
Thank you.
All right, that's pretty much the end of our presentation. Can we have any questions?
Okay. It can do everything. It can avoid any obstacle you place in that track.
Even on the inside?
Yes, on the inside. You go any place that it can avoid it. Okay, Aaron?
You guys talked about the remote being very safe. So let's say the battery's down in your remote and you lose the connection. Does the car default immediately to e-stop state, or is it still able to drive around on its own? Sorry, I didn't really do that. Pardon?
I didn't hear the question.
So if the batteries on the remote die or you lose the connection, does the car immediately go into like e-stop mode? So like it'll only drive if it sees the remote says go.
The car will stop because obviously there's no power to the ESC. So yeah, it'll go into an e-stop.
Okay.
There's option in that.
Where in the communication stack does the e-stop signal actually happen? Like you get some infinite loop as you're processing on the car. Is that going to prevent it from seeing the e-stop signal?
For the e-stop, because we consider it an emergency, we send that signal everywhere, and everything that could react to it does. So it goes straight to the Arduino, which then tries to stop the car immediately. It also sends it up to the Beagle board, where it will also tell the Arduino to do a stop. So in case the Arduino for some reason ignores it or gets stuck and doesn't process it, the Beagle board will still tell it to stop. So we try and have that say stop everywhere possible, and not just one spot of failure.
I saw it sometimes, I don't know if it was on purpose, but your car was slowing down in some cases, like avoiding obstacles. I'm wondering what you're doing to tell it to slow down.
Yeah, I mentioned that. What we're doing is we're actually slowing down when we see obstacles. We incorporated this in because it's much more realistic scenario.
But then why was it only slowing down in some cases and not others?
It should be slowing down in all cases. I'm not sure if you were looking
It
at
just seemed like
Well,
as it started to avoid one, it would go slower, but as it was coming up, it was the same.
Sometimes it takes a bit to react. That could be it.
If you read Slashdot, you should read the physics paper that was recently posted for the guy getting the traffic ticket. It helped explain it.
Any further questions? Thank you very much.